Good afternoon and welcome to the latest Design World webinar. I'm Rachel Passini, Editor-in-Chief. I'd like to thank you all for attending this talk on advanced sealing solutions for sustainable eVTOLs, hybrid systems, and hydrogen aviation. We also thank our presenters, Dongyop Shin, Hirotaka Sato, and Bernard Landmeters for sharing their knowledge, as well as Omniseal Solutions, which is a Saint-Gobain company if you're in the US, or Saint-Gobain if you're located elsewhere. Once again, thank you very much to Omniseal Solutions for bringing this educational content to our audience and making this webinar possible. Now, I am happy to introduce our presenters. First, we have Dongyop Shin. He serves as District Sales Manager for the aviation market at Omniseal Solutions, where he brings more than a decade of expertise in advanced sealing technologies. In this role, he supports customers with high-performance sealing solutions that address the aviation industry's rigorous performance, safety, and reliability requirements. With a background in research engineering at Saint-Gobain and a Bachelor of Science in Chemical Engineering, Dongyop combines technical knowledge with customer-focused insight. His experience spans research and development, product management, and sales operations, enabling him to align engineered sealing solutions with evolving needs of the aerospace industry. Throughout his career, Dongyop has played a key role in advancing strategic initiatives for emerging aviation technologies, supporting Omniseal Solutions' mission to drive innovation and sustainability in next-generation aerospace and mobility applications. We also have Bernard Landmeters. He serves as product manager for Omniseal's rotary lip seals at Omniseal Solutions and is an active member of the value development team. In his role, he leads the strategic development, technical refinement, and market positioning for rotary lip seal solutions for high-performance applications. Drawing on extensive experience in Rulon, fluoropolymers, and advanced sealing solutions, Bernard plays a key role in aligning product capabilities with evolving customer requirements. His deep technical knowledge and cross-functional collaboration ensure the delivery of innovative, reliable, and efficient sealing solutions that meet the highest industry standards. Bernard began his career at Saint-Gobain more than 22 years ago as a design application engineer, later taking on positions as product manager for seals and quality manager. This diverse background has equipped him with a comprehensive understanding of sealing technologies and applications, establishing him as a trusted expert in the industry. Dongyop, Hirotaka, and Bernard, thank you so much for being here. I'll turn it over to you three so we can get started.
Thank you, Rachel, for the kind introduction. We wanted to kind of share some words about Saint-Gobain and Omniseal Solutions to start. We're part of the Saint-Gobain Group, which is a global leader with over 360 years of innovation. We have a strong presence worldwide and is committed to building a more energy efficient and sustainable future through advanced solutions. We develop and deliver materials that support energy renovation, lightweight construction, and the decarbonization of industries across all continents. With over 161,000 employees in nearly 80 countries, our group is driven by continuous innovation and performance to reach net zero carbon emissions by 2050, to grow its business through solutions that support sustainability, and to actively support the shift towards clean energy and green technologies. With more than 70 years of expertise, Omniseal Solutions, as I mentioned before, is part of the Saint-Gobain Group and Saint-Gobain's Performance Polymer Solutions division. And we specialize in precision sealing and material solutions for critical high-demand applications. Our technologies are built to perform in extreme environments, combining high-performance polymers and metals, serving key sectors such as aerospace, energy, industrial, life sciences, semiconductors, and nuclear. At the heart of everything we do is a commitment to a cleaner, safer, and more efficient world. Through co-engineering, rapid prototyping, and global manufacturing, we partner with our customers to solve complex challenges, especially in the areas of electrification and hydrogen. As part of the Saint-Gobain family, we combine global resources with deep technical expertise to deliver next-generation sealing technologies thanks to our shared mission, accelerating the energy transition and enabling sustainable flight with advanced sealing solutions. we have a broad and diverse portfolio of specialized sealing and material solutions for aerospace, supporting its critical applications. Our solutions are engineered to perform reliably in extreme conditions. So whether it's cryogenic temperatures, high pressures, corrosive fluids, or high-speed environments. What sets us apart is our ability to co-develop with our customers, combining deep materials and design expertise with advanced R&D capabilities. This expertise is reflected in our diverse portfolio of high-performance sealing and material technologies that can be custom engineered to produce bespoke solutions for the critical applications. Next, we'll go one product line at a time and give you a high-level view of what they are. First one is our Omniseal spring energized seals. So these consist of a precision polymer jacket and a corrosion-resistant metal spring that applies consistent force to maintain sealing integrity. These are ideal for critical leakage control, especially in extreme environments like high-temperature jet engines, but as well as cryogenic liquid hydrogen tanks and valves. They can also be found as retainer seals in engine bearing sumps and lubrication as well. Next is our rotary lip seals, also known as rotary shaft seals. These are built with a robust metal casing, and they excel in harsh conditions involving aggressive media, high rotational speeds, temperature extremes, pressure variations, or even in minimum lubrication conditions. They can be found in electric motors and propulsions, generators, pumps, and gearbox type of applications. Next is our metal seals. These are designed for the toughest operating conditions. They offer outstanding durability and leak tightness, whether for static face sealing in extreme pressure and temperature, or dynamic axial sealing with limited motion. So they deliver unmatched reliability over time, regardless of these configurations. Next three will be our material solutions, starting off with our Rulon fluoropolymers. So it's a family of engineered polymers used to produce custom components like bearings, piston rings, and wear parts. It offers low friction coefficient, high wear life, chemical resistance, and performance in demanding temperature and pressure ranges. So some of the typical examples would be as bearing parts, piston rings, and actuation compressors, or can be found in space systems as well. Next is our melded thermoplastics and polyimides. So these are parts that are molded or machined into precision parts for aerospace, semiconductor, or energy sectors. They're ideal when thermal stability, mechanical strength, and chemical resistance are non-negotiable. Some of the typical examples would be engine controls, connectors, and insulations. Last but not least, our high-carbon composite materials. These are advanced carbon and glass reinforced composites designed for dry running or high temperature applications where traditional materials fail. So they're commonly found in aircraft systems, turbines, and other high performance industrial applications. We'll go more in depth on more relevant product lines when it comes to electrification and hydrogen, and as well as use cases and where they can be found in later slides. But you've seen that our portfolio, our diverse and deep portfolio enables safe and efficient aerospace performance. And these are, as I mentioned before, especially critical for propulsion, hydrogen, and hybrid systems. Additionally, PFAS-free material options are available upon request to support evolving regulatory and environmental requirements. Our sealing solutions are created in the 50s. Our solutions are virtually part of all civil and military programs. As a result, we're a long-standing partner in aviation, supporting both airplanes and helicopters with proven track record in advanced sealing, wear, and friction control solutions. We leverage this know-how and expertise to sustainable flight. We partner with pioneers in eVTOLs, hybrid electric, and hydrogen aviation to understand their application and needs, which leads to co-engineering advanced sealing and material solutions for next generation propulsion, driving fast, safer, cleaner, and more efficient flight through innovation. This results in supporting customers in weight reduction, energy efficiency, and zero emission goals, to name a few of their goals. As I mentioned before, we have a very proven pedigree in the aerospace industry. Some of the applications we support in their aircrafts is found in the below diagram. Anywhere from jet engines, which in itself has more than 60 applications, to all the other areas of equipment, be that landing gear, nacelles, ECS, APUs, sensors, power electronics, fuel systems, and flight control, to name a few. All our product lines are represented in all of these applications, so we can be sure that we have the know-how and expertise that can translate to this next chapter of sustainable flight. Hybrid systems can be certified as supplemental type certificate, right? So what we frequently call STC, and they can use existing airframes for certification. And when they certify, specific portion of the aircraft, right? So say powertrain, and not a brand new aircraft category. And they can use today's airports, MRO, and operational rules. So, from both certification and maturity to market point of view, they're probably gonna be one of the earlier ones among the options. eVTOL will be a close second. So eVTOL is being certified, as we know, under a new powered lift category, right? New operation concepts requiring vertiport infrastructure. Some players, as we've seen in the news, will achieve certification much earlier, but the scale up will still take more time than the case for hybrid systems, most likely. Hydrogen, of course, will be a longer timeline as the technology is still being developed and maturing. But certainly, this is the only true way, as we understand it today, to decarbonize aviation industry. So R&D efforts are still ongoing. So to start, hybrid electric systems, I wanted to share some of the unique sealing challenges in these three topics before we go into specific product details, as well as some more use cases around our products in the actual applications in eVTOL and hydrogen. So as mentioned before, a lot of the many commercial and regional platforms are moving towards hybrid electric systems as a transitional solutions, while they go towards fully electric aircrafts for zero emission aviation, right? So these architectures combine fuel-based turbines with electric generators and motors, offering improved fuel efficiency, reduced emissions, and greater operational range. First thing first, high-speed shaft operation is one of the challenges. So generator shafts often operate at speeds above 11,000 RPM, and seals must remain effective under continuous high rotational loads. When it comes to compact and lightweight design, hybrid engines require seals that are space efficient and low in weight while maintaining long-term durability. Leakage control under variable conditions. Similar to traditional aircrafts, seals must maintain low leakage rates despite fluctuating pressures and speeds to ensure space system efficiency and environmental compliance. Last but not least, thermal-chemical resistance is important as well, and it's a unique sealing challenge here as well, right? Materials must withstand temperature variations and exposure to lubricants and fuels. So both chemical compatibility combined with the cycling effects of varying degrees of thermal and pressure requirements without losing sealing integrity. Next is eVTOL. So eVTOL aircrafts, as we talked about before, supports a new class of mobility, right? That includes urban and regional air transport, emergency medical response, and cargo delivery. These aircrafts rely on hybrid and electric propulsion units that must function efficiently within strict space and weight limitations while withstanding elevated thermal and mechanical loads. So thermal management point of view, from electric propulsion systems, it generates intense heat during high-powered operations. So materials must handle elevated temperatures without degrading. From system integration complexity, the tightly packed layout of eVTOL platforms requires seals that perform reliable in confined spaces with minimal clearance. And then when it comes to weight and space constraint, you know, even more so than traditional aircrafts, the battery limitations require every component to be as lightweight and compact as possible, right, to support the range and payload efficiency. And when it comes to environmental protection, of course, the systems are exposed to moisture, vibration, and airborne debris. So these seals must be able to protect internal components to ensure long-term performance and reliability. Hydrogen holds the greatest long-term potential here, especially for medium and long-haul travel where batteries are limited by weight. So, you know, it's widely accepted as the only true way to decarbonize the aviation industry, right? So many developments are taking place despite long time horizon view. For this, there are some obvious challenges for seals. First things first, cryogenic temperature resistance. So, you know, while gaseous hydrogen is being considered for some, for really medium and long haul travel, it'll be liquid hydrogen, right? So liquid hydrogen must be stored and transported at temperatures below negative 250 C or negative 482 Fahrenheit. And seal materials must stay still flexible and effective in these cryogenic conditions. Permeation is another challenge here, as hydrogen molecules are extremely small and can permeate many materials, right? So not only the leakage, we have to also think about permeation through the seal materials. Seals must have very low permeability and precise geometries to prevent leakage. Pressure and thermal cycling. So fuel systems experience rapid changes in pressure and temperature. So it's quite a, you know, ubiquitous kind of challenge that we see from seals' point of view. But of course, this fluctuations place mechanical stress on seal interfaces, right? And it can cause long-term material fatigue. So again, this is where our materials and design expertise in seals come to play. Last but not least, chemical compatibility from the point of view for more continuous hydrogen exposure. So long-term stability is essential to maintain system safety and performance. So again, these challenges require precision engineering solutions designed to perform reliably and safely. So in the next few slides, we'll see how each of the product lines can do that due to its unique characteristics as well as use cases. Yeah, so rotary lip seals, absolutely. Bernard, I'll turn the table to you to discuss some key advantages of our rotary lip seals.
So let's see why this technology installs in hybrid electric systems. So our Omniseal rotary lip seals are their elastomer lip seals and mechanical lip seals. Our rotary lip seals consist, as Dongyap already mentioned, of a metal case, but a static sealing on the outer diameter of the seal, and with a 1 or 2 PTFE-based sealing lip to seal on the shaft. Typical speeds for our rotary lip seals can withstand up to 35 meters per second. And also with special designs, we can even go up to 100 meters per second, also depending on other application conditions, of course, from the applications. Also, the pressures up to 35 bar are no problems for our rotary solutions. The wide temperature range can also be seen as a key benefit, ranging from minus 50 degrees C up to 230 degrees C. And that is helping us to achieve high sealing performance in this application. So thanks to the unique composition of our sealing materials, they can reduce the wear and achieve a long lifetime. So the rotary lip seals are critical for durability, efficiency, and reliability in both eVTOL and hybrid electrical systems. So now let's move to another group of materials, the Meldin materials and HiCom composites. Meldin is the brand name for our polyimide-based materials, and HiCom composites are also polyimide-based materials, but they are reinforced with graphite, carbon, or glass fibers. Typical temperature ranges for the Meldin materials are from minus 268 degrees C up to 316 degrees C, and with mechanical strength up to 40 megapascal and a low coefficient of friction between 0.12 and 0.20. For the HiCom composites are from minus 140 degrees C to 320 degrees C, and mechanical strength can go up here up to 710 megapascal. Key advantages for these materials are the lightweight compared to the metal components while maintaining its strength, so up to 40% lighter than aluminium and up to 75% lighter than stainless steel and titanium. They also have very good dimensional and mechanical stability at elevated temperatures. And so thanks to this, also complex parts can be machined out of these materials. And as already mentioned, they can also withstand high loads and have a good wear resistance in combination with low friction. And last but not least, they're also good thermal insulators. So these hydrogen-ready materials offering cryogenic resilience and permeation control, and so critical for eVTOLs, electric aircraft, hydrogen systems, and high-temperature aerospace applications. And so together, they enable safer, lighter, and more efficient project management.
So certainly when it comes to hydrogen sealing, we have polymer and metal seals that we can utilize. The key advantages here for this either Raker design, which are also quite on the left, as you can see. We use it quite often for space applications as well, and as well as you see the metal E-seal that can be utilized. So, you know, Raker seal, polymer seal for hydrogen turbopumps and tanks applications. We see a lot of metal seal application for hydrogen feed line sealing applications. But the key advantages here is certainly the first and foremost cryogenic compatibility. So reliable sealing from the cryogenic temperature from negative 254 Celsius to 250 C or above. Extreme pressure resistance up to 100 megapascal, low leakage and permeation control. So these are proven solutions in the field already, ensuring hydrogen containment, and system efficiency. They're also resistant to hydrogen embrittlement, fuels, and aggressive media, right? So this chemical compatibility is certainly a advantage. On top of that, you know, where there's a limited, perhaps motion associated in this otherwise mostly typically static application, we provide controlled friction and durability. So reduced wear, long service life, and high-speed dynamics is certainly a key as well. So we'll cover this more in the next slide, where we have applications within the hydrogen aviation, but you can see that these solutions are critical for hydrogen aviation. And they ensure safe, efficient, and reliable operation under the most extreme aerospace conditions. Next two slides are going to be examples of where our solutions can be found in hydrogen and eVTOL applications. So bespoke sealing and material solutions in hydrogen applications can be found in the tanks, fuel cells, compressors, pumps, feed line pipes, right, valves, and conventional motor applications as well. They'll be using the electrical power, you know, derived from hydrogen fuel, of course. So in the hydrogen tank applications, you can see you can utilize our static solutions, whether it's the polymer or metal. So for polymer, our spring energized seals and metal or metal seals. depending on the leakage requirements, depending on other environmental conditions that would be more conducive for one product line or the other. So those two static sealing solutions allow for extremely low permeation or diffusion, even under cryogenic temperature and high pressures. For fuel cells, we got the Raker seals or metal seals. So they have good chemical compatibility in the media for fuel cells, whether it's potassium hydroxide or else, and they have extended lifetime. That's been indicated by other our PTFE and our material solutions there. And then our compressors applications, you can see our polymer or metal seals or polyimide bushings. So limited friction to prevent leakage application there. The pumps, quite similar to sort of in our energy market where we're limiting the friction and wear in the extreme conditions. So whether it be liquid hydrogen, high pressure, or high-speed dynamic motions, we have the know-how to optimize for the lifetime. So there are a lot of considerations to be had, as you can see, when you're considering a sealing solution. And for feed line and pipes, you can see that, again, here, low permeation to prevent the leakage, as well as the low temperature capabilities in this type of cryogenic conditions. So we got the Raker seals or the clamps that can be used in high pressure environments, whether inside the valve or the pipes or the outside as a clamp that's required additionally. And then you got the valve applications. Again, similarly, you got the reduced friction and low permeation characteristics that's required, but also resistance to rapid gas decompression, rapid gas decompression, RGD, to prevent leakage. So here's another example of our know-how transferring from oil and gas energy markets that we have extensive know-how in. And last but not least, somewhat crossover with the eVTOL here and the conventional and e-motor applications, which will go more in depth. But in the next slide, electrical insulation, high-speed solutions, all these characteristics that are needed in extreme temperature and chemical compatibility. Next is the bespoke sealing and material solution in eVTOL applications. Here you can see that it's sort of grouped by subsystems. So starting from the left, you got the propeller and transmission systems, followed by flight control systems, sensing systems, power electronic systems, environmental control systems, and APU. To start with, maybe we can go by product line that's kind of seen transversely throughout these subsystems. If you look at the rotary lip seals, as Bernard had mentioned before, rotary lip seals are widely used in electric propulsion systems, particularly in electric motors, where they help maintain long-term performance with low friction materials under demanding operating conditions. These seals can include wiper element that prevents contaminants, environmental factors such as dust, moisture, and debris from entering sensitive internal components. At the same time, they help retain lubricants within bearings and moving parts. Right? This helps it reduce friction, supports energy efficiency, and minimize wear. Their compact form factor and resistance to thermal and mechanical stress, right, makes them really well suited for environments such as this in a very space-constrained environment, like e-motor housings and propulsion unit assemblies that we see in eVTOL and urban air mobility aircrafts. Now, if you look through the lens of polymer-based composites and polyimides that are used in electric propulsion systems, certainly we use their advantages in their ability to combine thermal resistance, electrical insulation, and dimensional stability in a compact form. So these materials are well suited for components exposed to high temperatures, and voltage stress, which can be found in propeller assemblies, flight control systems, and power electronics. Polar amides retain mechanical strength at continuous temperatures above 300 C or 572 Fahrenheit, helping manage heat in these very tightly integrated systems. Also, their low moisture absorption and dielectric strength support long-term insulation performance in very high voltage environments. So another example like I'll bring our focus to is sensing systems in the middle, where our Omniseal spring energized seals used. So where you want low friction but controlled friction, say in the controlling the movement of the sensor, while offering long lifetime. It's really essential that advantage and characteristics that spring energized seals can offer. You also see some examples of assemblies. So not only do we provide sealing solutions and material solutions, we can also offer assemblies to help really help our customers be one-stop, go through us and use it as a one-stop shop to ease the supply chain in terms of combining multiple parts into one, right? So we see some examples here in the power electronic systems, where you see a terminal block on the right, and you see diode housings on the left. But essentially, by utilizing polymer materials here, we're saving more than 40% when compared to using when compared to the existing solution that was metal. So there's certainly weight savings there, but as well as the vibration resistance and electric isolation was a big part of it. Similar to that, you see a flat gasket example up on the right, environmental control systems, where you have sort of metal gasket combined with our spring energized seals. So again, combining two different components for easier integration, and providing this and not having to really, in this case, play around or modify the existing hardware to make a gland for seal too, right? So there are many advantages that can be had from this type of assemblies that we can also offer. A lot of the thermoplastics on the right side and the melded parts are also for lightweighting, similar to what I showed in the power electronic systems, but also component consolidation. So I think takeaway here is certainly that existing solutions used to use multiple metal parts in the same application, where we can come with either assembly or thermoplastics or melded product line with just one complex geometries to solve, to be able to seal and perform in that application. So I hope this paints some pictures, some examples, some high-level views on where our products are typically used in eVTOL and hydrogen applications. With the limited time, we try our best to showcase some of the examples here, but please feel free to reach out to us further for your very specific application and needs. As mentioned before, our business model is definitely to co-develop, co-engineer with our customers to help with their critical and very specific projects. So this brings us to the end of our presentation. Thank you for your attention. Please visit our website for more case studies, white papers, and more resources in general to know and learn more about how our products and services can support your projects.